In this example, we're also going to be decomposing numbers additively, but this problem is going to be a little bit different. Let's read the problem carefully. Deb, Frank, and Sarah pooled their money together and had a total of 10 $1 bills. Determine all the possible amounts they may have originally had if they each had at least $1. Again, you do not need to distinguish between who had what amount. So notice this is very similar to the last problem. The only difference is there's not just two people, now we have a third person, Sarah. So let's go ahead and highlight our givens. These three people pooled their money together and they had a total of 10 $1 bills. And we also had down here, we do not need to distinguish between who had what amount. Now our goal begins with the word determine. Determine all the possible amounts they may have originally had if they each had at least $1. Okay? So we know what we know, the givens, and we know what we're trying to find, the goal in blue. So notice I have a table ready. It has 3 columns now since we have 3 people. You should make this table in your mini lesson packet. And I have the 10 $1 bills ready for our partitioning. So this is going to start just like we started before. I am going to give $1 to the first person, since we know that each person has at least $1. Now I'm going to draw another partition line here. This will be for the second person, and the remaining 8 will be for the third person. Okay. So we have $1, $1, and $8. But now notice that there are many combinations, if we move away this partitioning, many ways to split these 9 $1 bills between the second and third person. This is how it's different from the last problem. So we're going to fix this first person having $1 and then find all of the ways that we can split the $9 between persons 2 and 3. So we found the first one when the second person has 1. Now let's find when the second person has $2. So here we have $2 and here we have $7. So 1, 2, 7. Now we're going to continue on just like we did before, 1, 2, 3, until we see that the amount of dollars on this side would be less than the number of dollars in this partitioning. So we have 3 and 6. So 1, 3, and 6. Okay, our next partitioning would be at 4, and this gives us 1, 4, and 5. Now let's see what happens if we move it over one more. It would be 1, 2, 3, 4, 5. The third person would be over here. And we'd have 1, 5, and 4. But notice we already have 1, 5, and 4. We just have it in a different order. So when this number here, if we were to put this here, gets larger than or equal to the number in the right-hand column, that means we're done with that series of combinations. So we have found all the combinations where one of the people has $1. So now we're going to move on to when one of the people has $2. Let's move these over a little bit. So the first person has $2. Let's put a 2 here and a 3 here. Okay. Now notice we already have one of the combinations where one of the people has $2, 1, 2, 7. So we need to make sure we don't include any combinations that have a 1 in it. Then we'd be repeating 1, and we don't want to write any combination multiple times. So we're going to have 2 and 2 as our starting point, and this gives us 2, 2, 1, 2, 3, 4, 5, 6. 2, 2, and 6. Now we're fixing the first person at 1, or at 2, sorry. Now we're going to move this over. 2, 3, and 5. Okay, let's see if we can still keep going. 1, 2, 3, 4. This would give us 2, 4, and 4. And 4 is not in this last column, so that means that this is still a combination we haven't gotten yet. But notice if we made the second person go up to 5, we would have that combination here. So we're all done with the cases where one person has $2. So next we'll move on to 3. So the first person has 3, and again we don't want to have any combinations with $1 or $2, so the second person needs to have 3. So this is 3, 3, and 4. Okay. Now let's see what happens if we move this line 1 over. 1, 2, 3, 4. Well, notice this would be 3, 4, and 3. But the last one we got is actually the same as 3, 4, and 3. It has 2 3s and 2 4s. So notice if we had increased this number by 1 to a 4, we already had that in the column right here. So we actually have all of the combinations with a 3 in it. Let's see if there's any with 4s to make sure that we haven't skipped any. So 1, 2, 3, 4, or any left with 4s. 4 for the first person. We'd need 4 for the second person. This would be the second person's. And this would give 2 for the third person. Okay. Now notice we actually already have this combination as well. Since the third number went below 4 to 2, and we had already gotten all the 2's, this should be in our list. And notice it's right here. So after we found 3, 3, 4, we're completely done. So we found all of the combinations and we already found this one. So now let's type our final answer. 1, 1, 8, 1, 2, 7, 1, 3, 6, 1, 4, 5, 2, 2, 6, 2, 3, 5, 2, 4, 4, finally 3, 3, 4. So we have found all the possible amounts they may have originally had if they each had at least $1. And there's 1, 2, 3, 4, 5, 6, 7, 8 different ways.